eukaryotic organisms different. I further every kind of the organisms I summarize 84 state. Today we begin to study the structure of the human genome. Right. From this figure, last times I explained for you. You can see for the human being, the genome includes the nuclear chromosome and the mitochondrial DNA. So totally, the two parts, totally, we see it is the human genome. Here you pay attention to, you can see the mitochondrial DNA molecular, you can see is smaller molecular compared with the chromosome DNA. You can say only coding 37 gene, including the 13 coding the protein. The protein, all over the protein, you can say it is the component of the oxidative phosphorylation. We study, you can say complex 1, complex 2, complex 3, complex 4. It is a subunit of the all of the complex. And another, you can see here coding the 2 Robertson RNA, 22 tRNA. Maybe here some students maybe think for this allele, for the mitochondria, all these 37 gene, it is enough for the mitochondria. Most of the protein, most of the gene products come from the so in the later we studied, you can say translation and modification and the maturation and the protein, another process, transportation. And another, you can see here, for occupies 25%. And 75% it is the DNA sequence and label coding some products, including the interval synthesis between the coding gene, spot gene. And another, you can see, and most of the middle or highly repetitive sequence. And here, my students pay attention to the structure gene. You can see only percent, the 1%, it is the take part in coding the protein, coding the RNA. And most, it is forms the intron. Last time we studied, you can see for the eukaryotic organisms, forms the splicing gene. The splicing gene, you can see, contains plenty of the intron. Okay. This table, last time we studied, you can see, until now I find the 28.9 thousand genes, about 25 of the genes encoding protein, and other coding the RNA, all encoding the RNA. And here you can see most of the genes belong to the housekeeping gene. For every cells, it is necessary. For example, just we see the oxidative phosphorylation. Most of the cells, it is the necessary. So 10% genes belong to the luxury gene. For the people, you can see, come from the Africans, come from the Asians, come from the Americans, it is all the genetic difference among different species, come from different country, different strata. You can see the difference is very, very small. You can see below 0.01%. Is so small. Okay, just the way I explained for you, most of the DNA molecular, you can see, forms the middle and the highly repetitive sequence. Later, we began to study this part. Repetitive sequence in human genome. Because there are usually a large number of the repetitive sequences in the human genome, which account for more than 70%, occupies the whole genome's DNA. Here, must pay attention to what kind of the repetitive sequence. It is the highly repetitive sequence. You can see the frequency right to above 10 times 7. And at times, this kind of the repetitive sequence we see is highly repetitive sequence. And another, you can see for the moderately repetitive sequence, you can see 10 to 10 times 7 or 6. This kind of the repetitive sequence, it is a moderately repetitive sequence. According to the frequency, we divide 3 kind of the repetitive sequence. And the last one, you can say single copy gene. All of the protein coding genes, it is a single copy gene, a single copy sequence. Here we studied this part. You can see for the highly repetitive sequence, you can see repetition times is very high, up to the million times. Here at too long find the standardized DNA, it is the highly repetitive sequence. And secondly, you can see inverted repeated sequence. And another one you can say, and too long don't find the low, the complex repetitive sequence. For this part, we focused on these three kind of the highly repetitive sequence we studied. Okay, the first standardized DNA. Here, this kind of the DNA, you can see. You answer what is standardized DNA. The first, this is the one kind of the highly repetitive sequence in the genome. The repeated unit are composed of the 2 to 10 base pair.说上课在办公室，你给送过来，双面打印，上下载同一个专利，不行，好。And some of the repetitive standardized DNA are 20 to 200 base pair. So maybe some students think, why gives this name? This kind of the DNA molecule, you can see, when you extract it from the steel, at that times, through the phage, at that times, you can see, all the times, and find this kind of sequence maybe forms, you can see, forms the spatial band different to the main band, and this band you can see beside the main band. So same to the standardized. All the times you can see this kind of the sequence, the guanine and cysteine maybe is highly. This my students pay attention to through the isodensity gradient certification. At that times, you can see in this tube, you can see beside the main band, beside there is the DNA molecular band. Similarly to the centenite. So give this kind of the sequence. Give this kind of the sequence is the name. It is centenite DNA. So my students answer this question. The first one kind of the for the satellite DNA, the first it is the one kind of the highly repetitive sequence in the eukaryotic organism. The composed of the 2 to 10 base pair. Sometimes some of the satellite DNA composed of the 20 to 200 base pair. The composition. And second, another one you must answer. This kind of the genome through the isodensity gradient certification. At that times, the satellite DNA, because the satellite DNA different to the other part of the DNA, so can be separate at each other. All the times, beside the main band forms the satellite band. This forms the satellite band, the DNA. It is the satellite DNA. Totally answer this question. Through this certification and forms the band. Okay? This, do you understand that?
Yes.
Okay. Second kind of the highly repetitive sequence. It is inverted repetitive sequence. Here in this PPT, I write the model. You can see here, this also, it is a highly repetitive sequence. The composed of the complementary sequence of the same sequence. The double-stranded DNA of the reverse pit is separated, and the hairpin structure and the cross structure are formed easily. Like this, you can see, can be forms the hairpin structure. 怎么？这样，邓总过来等一下，那个什么吴总噻。嗯嗯嗯嗯。And another kind of the repetitive sequence, you can see the complex repetitive sequence. You can see here the complex nucleotide sequence are common in mammals. All kind of count the 那个什么the lines, element, and so on. This kind of the sequence is very common. And genomes don't find the regular. And here, for this, always for the highly repetitive sequence, maybe stirs in the telomeres, in the centromeres, and so on. So here, not the one. All of this kind of the sequence never take part in the coding function. For this kind of the repetitive sequence, what kind of the function? You can say function of the highly repetitive sequence. Take part in to form chromosome pair. And another one participated in the regulation of the replication. And another one take part in the regulation regulated the genes expression. Here for the highly repetitive sequence. This three facet the function. Just we see is you can see always presented in the centromer. Here you can see the chromosome. You can pair each other from here. And another one you can see regulated replication, regulated the transcription, regulated the genes expression. Okay. For another one, for the moderately repetitive sequence. For this kind of the sequence, you can see here list the two kind of the sequence. Here you can see for this, you can see the frequency is small than smaller than the higher repetitive sequence. The sequence that enter the repeated over the dozen times to the hundreds of the thousands times in the genome. Here I listed, you can see, short interspersed nuclear elements, and another one is non-interspersed nuclear elements. Here, for my students, pay attention to this kind of the fragment. Here you can see the typical short interspersed nuclear elements are ALU repetitive sequence family, where licensed by the restriction endonuclease ALU, touch point ATCT, and this kind of the moderately repetitive sequence and two forms below, you can see this figure, and is the forms this three kind of the sequence. Two sequence, you can see 130 base pair, and another one in the middle, you can see 31 base pairs sequence. So for this kind of the short interspersed nuclear elements, give the name. It is the ALU sequence. ALU family. You maybe in the future ask you, what is the ALU family? What is the ALU sequence? You answer this question. This is one kind of the moderately repetitive sequence. In the eukaryotic organisms, one. Second, this is the one kind of the typical short interspersed nuclear elements. This repetitive sequence licensed by the restriction endonuclease AAU and forms the classical three kind of the sequence. Two sequence, the length, it is the 130 base pair. And another one, it is 31 base pair. This moderately repetitive sequence, it is the ALU family. All ALU sequence. Okay. This you understand another one. KPN1 sequence. You can see this sequence, you can see maybe latticed and similar to the ALU and produced the certain length sequence. And second, you can see for the moderative sequence, what kind of the function? You can see the sum of the moderative sequence belong to the structure gene. For example, the Robertson RNA, histone protein, the immunoglobulin, and the tRNA gene. Here, this stable kind of the products structure genes you must remember. Histone, the tRNA, and the Robertson RNA, immunoglobulin. These structure genes are often and forms the 10 in the genome. So this is the belong to the tandem repetitive sequence. And another one always forms the transportable elements. It is the moderately repetitive sequence. The frequency of the histone protein is different. Like this arching repeated 1,000 times. Fruit flies repeated about the 110 times, and Hemier Haston repeated 30 to 40 times. And the last kind of the sequence, it is the single copy sequence. You can see appeared only one times or several times in the genome. This kind of the sequence will give the single copy sequence. This belongs to the structure gene. Except just with this four kind of the genes are all of the structure gene. It is a single gene sequence. And for the genome, another one, the mitochondrial DNA. Eukaryotic organisms' mitochondrial DNA is independently encoding the peptide gene. Robinson RNA, tRNA, totally it is the 37 gene. Mitochondrial DNA, it is the double-stranded cyclo DNA with the molecular structure as the DNA of the prokaryotic organism. So many scientists think the mitochondria come from the prokaryotic organism, from their evolution. Think like this. And Hamer's mitochondrial DNA is full length, 16.57 kb, contain 70 or 37 structure gene. And last in here for the structure and the function of the various genome. Summarize 5 facets. The genome is small and very greatly. Always the hostile, it is the eukaryotic organism. The structure maybe is the more largely. Maybe the hostile, it is the bacteria. The genome is more small. And the composition changed greatly. Yeah, maybe is the RNA, maybe is the DNA, maybe contains protein gene, and so on. And here, always we think the genome structure similar to the histone, HOST. And the third, you can say overlapping gene is very common. And some various genes can form polycystic messenger RNA. And feeder genes, it is continuous. Whereas some eukaryotic organisms, various gene, it is discontinuous. So for the various the structure and the function, we summarize 5 facets. For genome, this chapter, we study this part is enough, is okay. And we reached 10 minutes. And next class, we begin to study the replication.